Hi everyone and welcome to video number 3 of applications of differentiations. So today I'll be showing you how to find tangents and normals to a curve using differentiation. Alright, let's learn how these work in today's video. Alright, so look at gradients, tangents and normals. Now remember that a gradient is a slope to a curve, at least you know what that is, or a slope to a line. But now we can also see that the gradient of a curve acting at a point is also the gradient of the tangent to the curve at that point. Then we also look at the fact that the tangent to a curve at a given point is a straight line which just touches the curve at that point. The gradient of the tangent is equal to the derivative of the curve evaluated at the point where the curve and the tangent line meet. And then the normal to a curve at a given point is a straight line through the point at right angles to the tangent at the point. Now consider a tangent and a normal at a point P, A, B on a curve y is equal to fx as shown below. So here you can actually see the curve is drawn in pink, and then we actually have the line. This line that is not dotted is the line representing the tangent. So it touches the curve at one point. Then you can see the normal is the one that is dotted, and we're saying it is a straight line through the point at right angles to the tangent at the point. That's why you see 90 degrees here, so it's at right angles. So PAB is the point, so the point is actually here where the curve and the line meet, where actually everything meets. And then we can see that the tangent at point P is this line here, and then the curve is y is equal to fx, and the normal at P is given at the dotted line. The gradient function dy dx is equal to f prime x gives the formula by which the gradient of the tangent at any point on point PAB, where x is equal to a and y is equal to b. So substituting these values in the gradient function gives the gradient m1 of the tangent at that particular point. So for example, m1 is equal to f prime x. So given the gradient m1 and the point PAB, the equation of the tangent at the point P can be got from y minus b over x minus a being equal to m1. And then, since the normal and the tangent are perpendicular to each other, we find the gradient of the normal m2 from m1 times m2, which is equal to -1, of which m2 is equal to -1 over m1. Therefore, the equation of the normal at point PAB can thus be got from y minus b over x minus a being equal to m2. So these are the equations that you should actually memorize, and they'll be useful as you follow the different examples. Alright, let's look at example number 1. So we're being told to find the equations of the tangent and normal to the curve x squared is equal to 4y at the point 6, 9. Alright, so the equation to the curve is x squared is equal to 4y. So first of all, I'm going to make y the subject, and y shall be equal to x squared over 4. So next, I'm going to differentiate this. So to find dy dx, we'll have dy dx being equal to x over 2. Alright, so now that I know the value of dy dx, I can look at the point 6, 9. So at the point 6, 9, we can say that the value of x is 6. So you can actually substitute that into the value of dy dx. So therefore, dy dx should actually be equal to 3. And then we can actually remember that now we know the value of dy dx. Remember the gradient of the tangent m1 is equal to 3. So remember the gradient of the tangent at a point is equal to the gradient of the curve at that point. So that's why we have m1 being equal to this 3. So equation of the tangent at point 6, 9 is got from y minus 9, which is y minus this 9 over x minus 6 being equal to this 3. And then if we cross multiply, we'll have y minus 9 being equal to 3x minus 18, of which if I make y the subject, y shall be equal to 3x minus 18 plus 9, which is equal to y being equal to 3x minus 9. Now that is the equation of the tangent. Alright, so next, let's look at the gradient of the normal m2. So you can find the gradient of the normal m2 from the formula m1 times m2 is equal to -1. So m2 is equal to -1 over m1, but we know what m1 is. m1 is 3. So m2 is equal to -1/3. So now therefore, the equation of the normal at point 6, 9 can be equal to y minus 9 over x minus 6 being equal to m2 or -1/3. So if I cross multiply, I'll have 3y minus 27 being equal to negative x plus 6. And if I make 3y the subject, 3y shall be equal to negative x plus 6 plus 27, of which 3y shall be equal to negative x plus 33. So next I can divide all sides by 3. Alright, so when you simplify this, I'll have 33 divided by 3, which is 11. So therefore, the equation of the normal shall be equal to negative x over 3 plus 11. So this is the equation of the normal, and this shall be the equation of the tangent. So question number 2. We're being told that given that y is equal to x cubed minus 4x squared plus 5x minus 2, P is the point on the curve where x is equal to 3. Calculate the y coordinate of P, that's part 1. Part 2, calculate the gradient at P. And then part 3, find the equation of the tangent at P. Then we've also been given part 4 to find the equation of the normal at P. Part 5, find the values of x for which the curve has a gradient of 5. So let's solve this. So now this is the equation of the curve, y is equal to x cubed minus 4x squared plus 5x minus 2. So first of all, we've been told that we're dealing with the point where x is equal to 3. So that means we can find the value of y. So substitute for x and we will find y being equal to 4. So now we know the value of 4. So the point is actually point 3, 4, 3, 4, 3,4. So now that we know that, we can look to part 2. So we're being told to calculate the gradient at P. So that means we basically just have to differentiate this equation. So dy dx shall be equal to 3x squared minus x plus 5. And then at point P, 3, 4, and we'll find dy dx shall be equal to 8, and that shall be the gradient at P. So next, we're being told to find the equation of the tangent at point P. Alright, so first of all, the gradient of the tangent m1 shall be equal to 8, because we've already seen that the gradient of the curve at that point is also 8. So to find the equation of the tangent at 3, 4, we'll have y minus 4 over x minus 3 being equal to 8. So when you cross multiply, I'll have y minus 4 being equal to 8x minus 24, of which if I make y the subject, y shall be equal to 8x minus 24 plus 4, which shall be y is equal to 8x minus 20. So that is the equation of the tangent at point P. So next, I was being told to find the equation of the normal at P. Alright, so now we can find the gradient of the normal m2. So now we know that a tangent is perpendicular to the normal, so therefore m1 times m2 shall be equal to negative 1. So to find the gradient of the normal m2, m2 shall be equal to negative 1 over m1, which is the same as negative 1 over 8. So now I can find the equation of the normal at point 3, 4, which shall be y minus 4 over x minus 3 being equal to negative 1 over 8. Then if I cross multiply, I'll have 8y minus 32 being equal to negative x plus 3, of which if I make 8y the subject, 8y shall be equal to negative x plus 3 plus 32. And then 3 plus 32 shall give me 35. Divide both sides by 8 and I'll have y being equal to negative x over 8 plus 35 over 8, and that shall be the equation of the normal at point P. So the last question, find the values of x for which the curve has a gradient of 5. Alright, so for part 5 we have to remember that dy dx is equal to 3x squared minus 8x plus 5. So now at this point we've been told that the gradient is 5. So that means that we just place 5 where we have dy dx. So now if I take the 5 to the other side, I'll have 3x squared minus 8x being equal to 0. Now what I can see here is I can factorize out the x, so I have x into 3x minus 8 being equal to 0. So you can see that either x is equal to 0 or 3x minus 8 is equal to 0. So from here I can see that if I take this negative 8 to the other side, I have 3x being equal to 8, of which if I make x the subject, x shall be equal to 8 over 3. So therefore the values of x are 0 and 8 over 3. So question number 3 is a question from UNEB 2019, and this was question number 5. So being told to find the equations of the tangent to the curve y is equal to a cubed over x squared at the point P. So the points P are a over t at the x and a.t squared at the y. Alright, so let's solve this. So I have the equation of the curve being equal to y is equal to a cubed over x squared. So this can be rearranged as a cubed times x to the power negative 2. 2. So when I differentiate that, I'll have dy dx being equal to negative 2a cubed x to the power negative 3. So we're going to consider that value of a as a constant, so that's why it's not affected. Alright, so now if I take x to the power negative 3 down, I'll have it as negative 2a cubed over x cubed. And then at the point P, a over 2 comma a.t squared, I can say the value of x is a over t. So plug that in and that's what I have. Alright, so now put this cubed in and I'll have a cubed over t cubed. So this divide by that, if I actually change that to a multiplication sign, I'll have t cubed going to the top and a cubed remaining down. So I'll have dy dx being equal to negative 2a cubed t cubed over 3a cubed. So I can see that the a to the power 3 values cancel and I'll be left with dy dx being equal to negative 2t to the power 3. So therefore I'll have the gradient of the tangent m1 being equal to negative 2t to the power 3. Now we can say the equation of the tangent at the point a p a over t comma a.t squared shall be that. So I have y minus this a.t squared over x minus this a over t being equal to this value of the gradient. So now next I can say that I can make t the LCM here and I'll have xt minus a over t. Alright, so next I can say this t value will go to the top, so I'll have t into y minus a.t squared over xt minus a being equal to negative 2t to the power 3. So when I cross multiply, I'll have t into y minus a.t squared being equal to negative 2t cubed into xt minus a. So first of all I can say this t reduces with 1 power of that, so I'll have y minus a.t squared being equal to negative 2t squared into xt minus a. So when I open brackets, I'll have y minus a.t squared being equal to negative 2xt cubed plus 2a.t squared. So if I make y the subject, y shall be equal to negative 2xt cubed plus 3a.t squared, because when I add this to this value, I have 3a.t squared. And therefore, if I actually rearrange this, I'll have it as y is equal to 3a.t squared minus 2xt cubed, and that is the answer. So therefore, the equation of the tangent is y is equal to 3a.t squared minus 2xt cubed. Alright, so the next question is question 4. So being told to find the equations of the tangents to the curve y is equal to x cubed minus 6x squared plus 12x plus 2, which are parallel to the line y is equal to 3x. So now something very important about two lines that are parallel is that they share the same gradient. So we have the equation y is equal to x cubed minus 6x squared plus 12x plus 2. So if I differentiate this, I'll have dy dx being equal to 3x squared minus 12x plus 12. Now since parallel lines share the same gradient, it means that the gradient of the tangent is 3. So I can just look here and I can actually pick the gradient of the tangent from this other line. So therefore, if I plug that in, I'll have 3 is equal to 3x squared minus 12x plus 12. So bring this 3 to this other side and leave a 0 and I'll have it that way. So 12 minus 3 will give me a 9. So I'll have 3x squared minus 12x plus 9 being equal to 0. So divide all sides by 3 and I'll have x squared minus 4x plus 3 being equal to 0. So when I solve this quadratically, I'll have x as being either equal to 3 or x being equal to 1. Alright, so now I can look at the two different points because I have two x values. So when x is equal to 3, I'll have y being equal to 11. So therefore, when x is equal to 1, I'll have y being equal to 9. So now I have two values of y and I have two values of x. So therefore, the tangents touch the curve at the points 3, 11 and 1, 9. And then, let's look at the equation of the tangent at point 3, 11. So plug that in and I have y minus 11 over x minus 3 being equal to 3. And then I'll have y minus 11 being equal to 3x minus 9, of which y shall be equal to 3x minus 9 plus 11. So if I simplify this, I'll have y being equal to 3x plus 2, and that shall be the equation of one of the tangents. And then let's look at the other point. So the equation of the tangent at point 1, 9, it will be 1 minus y minus 9 over x minus 1 being equal to 3. Cross multiply and I have y minus 9 being equal to 3x minus 3, of which if I make y the subject, y shall be equal to 3x minus 3 plus 9 and y shall be equal to 3x plus 6. So therefore the equations of the tangent are y is equal to 3x plus 2 and y is equal to 3x plus 6, and those are the answers they wanted. Alright, so question 5. We're being told to find the equation of the tangent and the normal to the curve y is equal to x squared into x minus 3 at the point where it cuts the x-axis. So this is the equation of the curve that we've been given. So when I open brackets, I'll have y is equal to x cubed minus 3x squared. Then when I differentiate that, dy dx shall be equal to 3x squared minus 6x. So now something important to remember is that at the point where the curve cuts the x-axis, y is equal to 0. So now I can use that to find the values of x. So now I can see that either x squared is equal to 0 or x minus 3 is equal to 0, of which x shall be equal to 3. So I have x as either being equal to 0 or x being equal to 3. So now there are two different points that we've actually found. Now there is the point, since the value of y is constantly 0, so there is the point 0, 0 and the point 3, 0. So now if I look at the point 0, 0 and I see what it will look like when I actually plug it here, I'll see that I'll actually just have a 0, and that's not going to be useful in this case. So we shall only consider the point where we have 3, 0. So the point p is equal to 3, 0. So that means at the point where we actually have y, of course y is 0 in all, but at this point here where 3, 0, I can say dy dx shall be equal to that, and then dy dx shall be equal to 9. So that shall be the gradient at that point. So the gradient of the tangent m1 is equal to 9 at that point. So the equation of the tangent at point 3, 0 shall be y minus 0 over x minus 3 being equal to 9, of which y shall be equal to 9x minus 27. And then the gradient of the normal at that point shall be m1 times m2 being equal to negative 1. Make m2 the subject and m2 shall be equal to negative 1 over m1, of which m2 shall be equal to negative 1 over 9. And then that shall be the equation, that shall be the gradient of the normal. Then to find the equation of the normal at the point 3, 0, I'll have y minus 0 over x minus 3 being equal to negative 1 over 9. So 9y shall be equal to negative x plus 3. Divide both sides by 9 and I'll have y being equal to negative x over 9 plus 3 over 9, which is y is equal to negative x over 9 plus 1 over 3. Alright, so question number 6. We're being told to find the equation of the tangent to the curve y is equal to 3x cubed minus 4x squared plus 2x minus 10 at the point of intersection with the y-axis. Alright, so y is equal to 3x cubed minus 4x squared plus 2x minus 10. So if I differentiate this, dy dx shall be equal to 9x squared minus 8x plus 2. So at the point where the curve cuts the y-axis, x is 0. So if I plug that in, I'll have y being equal to negative 10. So now we have one point, and that is the point 0, negative 10. So dy dx shall be equal to that. So now if I multiply that, dy dx shall be equal to 2. So that means that the gradient of the tangent m1 shall be equal to 2. So the equation of the tangent at the point 0, negative 10 shall be equal to y. Now it was going to be y minus 10, but because the 10 is a negative, it's going to be y plus 10 over x minus 0 being equal to 2. So I'll have it this way. So if I cross multiply, I'll have y plus 10 being equal to 2x. Make y the subject and y shall be equal to 2x minus 10. So therefore the equation of the tangent is y is equal to 2x minus 10. And that is the answer. Question 7. We're being told to find the values of x for which the gradient function of the curve y is equal to a quarter x to the power 4 plus 2 over cubed x cubed minus a half x squared minus 2x plus 1 is 0. Alright, so this is what we have. So if I differentiate this, I'll find dy dx being equal to x cubed plus 2x squared minus x minus 2. So now I've been told that the gradient function of the curve this is 0. So that means that dy dx is 0. So I'm going to have all these being equal to 0. When you have an equation like x cubed plus 2x squared minus x minus 2 being equal to 0, so we're going to use long division. Now I encourage you to look at polynomials of cubic equations to actually understand this further, but it's a topic that is covered earlier, so we shall be using long division in this case. But before we do that, I can see that the factor inside is 1. So if I actually make the x be equal to positive 1, I can actually see that it will actually give me a 0. So that means I shall be dividing by x minus 1. So now in long division, this is what I'm going to have. So I'm going to have this x cubed plus 2x squared minus x minus 1 dividing x minus 1. X cubed divided by x shall give me x squared. Multiply x squared here and I'll have x cubed minus x squared. So when I subtract this, I'll have, so 2x squared, minus negative this, it will be like 2x squared plus x squared, which is 3x squared, minus x minus 2. So 3x squared divided by x shall give me positive 3x. So multiply this in and I'll have 3x squared minus 3x. So when I subtract this, it's the same as negative x minus negative 3x, which is negative x plus 3x, which shall be 2x. So I'll have 2x minus 2. So 2x divided by x shall give me 2. 2 times this will be 2x minus 2. So when I subtract that, I'll have no remainder. So that means that we chose the right factor. So now I can see that what I have is x minus 1 times that. So we can see that either x minus 1 is equal to 0 or x squared plus 3x plus 2 is equal to 0. So x can either be equal to 1 or x can be equal to negative 1 or x can be equal to negative 2. And those are the answers they were asking for. Alright, so question 8, we're being told that the curve with the equation y is equal to ax plus b over x times x plus 2, where a and b are constants and it has 0 gradient at the point 1, negative 2. Show that a is negative 8 and find the value of b. Part 2, show that the gradient is 0 also at the point negative 1/2, comma, negative 8. Alright, so this is what we have. So y is equal to ax plus b over x squared plus 2x. So now we're going to differentiate this, but we're actually going to use quotient rule. So I'm going to let u to be equal to ax plus b, of which if I differentiate that, du dx shall actually be equal to a. Then we're going to let v be equal to x squared plus 2x, of which dv dx shall be equal to 2x plus 2. Now from quotient rule, when I substitute those values in, this is what I'll have. So now when I multiply this, I'll actually have it this way. So this times this will give me these values in brackets, and then multiply the a in and I'll have ax squared plus 2x plus 2ax actually. So now when I open these brackets, I'll have this value as you can see right there. So now next I can say that this and this can combine, and then I'll have negative ax squared. Then I can actually say that this and this will cancel. Then I can say that I'll be left with negative 2bx and then negative 2b. So this is what I have for dy dx. Alright, but we've been told that the curve has a 0 gradient at the point 1, negative 2. So therefore, dy dx is 0 at the point 1, negative 2. So now when I plug in the value of x, so this, where there is x, I'll place this 1. So this is what I'll have, and I'll equate everything to 0. So when I cross multiply, I'll have 0 being equal to negative a minus 2b minus 2b, which is the same as negative a minus 4b. And then if I pull out negative 1, I'll have 0 being equal to a plus 4b. Alright, so I can have equation 1 as a plus 4b being equal to 0. Alright, so to get the next equation, I need to find a point where I can actually plug in y is equal to negative 2. So I can actually give the original equation as well given. So for y is equal to ax plus b over x into x plus 2 at the point 1, negative 2. So where there is y, I'm going to put a negative 2, as you can see right here. Then wherever there is x's, we're going to put 1. So now I have negative 2 being equal to a plus b over 3, of which a plus b shall be equal to negative 6. So from equation 1, I can see that a is equal to negative 4b. So substituting for a into equation 2, I'll have negative 4b plus b being equal to negative 6, which is the same as negative 3b being equal to negative 6, and b shall be equal to 2. And then, therefore, since I know that, I can actually substitute the value of b back here, and I'll have a being equal to negative 8, and that is what they wanted in the first part. Alright, so part 2, we're being told to show that the gradient is 0 also at the point negative 1/2, comma, negative 8. Alright, so we're going to substitute in the value of dy dx that we had actually found. Then we're going to try that point. So at the point -1/2, -8, we're going to plug in those values. So wherever there is x, I'm going to put in -1/2, and then we know the value of a, and we also know the value of b. So substitute all those in. So when I put all those in, I'll have 8 times 0.25 plus 2 minus 4 over 0.25 minus 1 bracket squared. So I'll have 2 minus 2 over negative 0.75 squared. So this is the same as 0 divided by 0.5625, which is actually 0. So therefore the gradient is 0 at the point -1/2, -8. Question 9. A. We're being told to find the gradient of x squared over 25 plus y squared over 4, which is equal to 1 at the point 3, 8 over 5. And then part B, we're being told that the equation of the curve is x squared y plus 3xy plus y plus 3 is equal to 0. Then determine the gradient of the curve at the point P is equal to -2, 3. Then part 2, find the equation of the normal to the curve at P. So let's solve this. So part A, let's work on that. So we have to find the gradient in part A. So now this is what we have. So now first of all, I can find the LCM, and I'll have 4x squared plus 25y squared over 100 equal to 1. Cross multiply, and this will be 4x squared plus 25y squared is equal to 100. Then if I make 25y squared the subject, it shall be equal to 100 minus 4x squared. Then if I differentiate both sides, I'll have 50y dy dx being equal to -8x. So I'm differentiating this the way I differentiate implicit functions. That's why I do it that way. Then if I make dy the subject, dy dx shall be equal to -8x over 50y. So now at the point 3,85, I'm going to substitute in for the values of x and y. I'll have it this way. So this is the same as -24 over 80, which is the same as -3 over 10. So therefore the gradient is -3, 10 at the point 3,8 over 5. So now I know the gradient in part 1, and that is the answer. So in part B, we're being told that the equation of the curve is x squared y plus 3xy plus y plus 3 is equal to 0. Determine the gradient of the curve at the point P is equal to -2, 3. And then part B is the equation of the normal. Alright, so part B, part 1, so this is the equation of the curve. So actually we're going to differentiate it. So as you can see, this is a little bit complex because for these two parts, I'm going to differentiate by product rule. Then this is also product rule. So I'll have 2xy. So after using product rule, I'll have 2xy plus x squared times dy dx plus, when I also use product rule here, I'll have 3y plus 3x dy dx. Then I differentiate this, I'll have dy dx. Then the 3 obviously disappears when I differentiate it. So now the next step is I can open these brackets, then collect the terms that have dy dx together, and then separate them from the terms that don't have the dy dx. Then if I can extract out dy dx, this is what I have. Make dy dx the subject, and it will be equal to -2xy minus 3y over x squared plus 3x plus 1. So now the point -2, 3, I can plug in the values for y and 3, I mean for y and x, and that's what I'll have. So I have 12 minus 9 over 4 minus 6 plus 1, which is the same as 3 over -1, of which dy dx shall be equal to -3. So the gradient at that point is -3. So therefore, that is the gradient at the point -2, 3. So the gradient of the normal, remember, is the same as m1 times m2, which is -1. So remember, the gradient of the curve is the same as the gradient of the tangent. So that's actually going to be our m1. So m1 is -3. So that means that we can find m2 from this formula. So make m2 the subject, and m2 shall be equal to -1 over m1, which is -1 over -3, of which m2 shall be equal to 1/3. So now to find the equation of the normal at -2, 3, I can find it from y minus 3 over x minus -2 being equal to 1/3. So when I cross multiply, I'll have 3y minus 9 being equal to a plus x plus 2, of which if I make 3y the subject, 3y shall be equal to x plus 2 plus 9, and then 2 plus 9 is 11, and then y shall be equal to x over 3 plus 11 over 3. So therefore the equation of the normal at P is y is equal to x over 3 plus 11 over 3, and that is the equation of the normal at the point P. Alright, so next question is question 10. So being told to find the points on the curve y is equal to 4x cubed minus 15x squared minus 18x, on which the tangent to the curve is parallel to the x-axis. Alright, so when I'm given such a question, I would just ask myself, what is the gradient of the x-axis? Because the tangent we're being told is parallel to the x-axis. So the gradient of the x-axis is 0. So that means that the gradient of the tangent is 0. So if we're given that the curve is y is equal to 4x cubed minus 15x squared minus 18x, if I differentiate that, dy dx shall be equal to 12x squared minus 30x minus 18. And then we've said if tangent to a curve is parallel to the x-axis, it means that dy dx is 0. So that means I'm going to put a 0 where there is dy dx. So first of all, I can divide all through by 3. So when I do that, I'll have 2x squared minus 5x minus 3 being equal to 0. So now when I solve this quadratically, I can find x as either being equal to 3 or x being equal to negative a half. So now when x is 3, I can see that y shall be equal to negative 81. And then when x is equal to negative a half, y shall be equal to 19 over 4. So therefore, the 2 points are 3, negative 81, and negative a half, 19 over 4. And those are the answers they wanted. Question 11. Find the coordinates of the point on the curve y is equal to a third x cubed minus a half x squared minus 4x plus 5, on which the tangents are parallel to the line through the points negative 1, 1, and 1, 5. So now first of all, we've been told that the tangents are parallel to a certain line, and that line passes through 2 points. So first of all, it means we can actually first find the gradient of this line that they're parallel to, because we know the points which this line passes through. So the gradient of that line can be found from m is equal to y2 minus y1 over x2 minus x1. So m shall be equal to 5 minus 1 over 1 minus negative 1. So m shall be 5 minus 1 over 1 plus 1, which is 4 over 2, and m shall be equal to 2. So since the tangents are parallel to this line, they share the same gradient m. So therefore the gradient of the tangent m is equal to 2. So now inside this equation, y is equal to a third x cubed minus a half x squared minus 4x plus 5. I can differentiate that and I'll have it as x squared minus x minus 4. So since the tangent cuts this curve, then dy dx is equal to 2 because they have the same gradient at that point. So remember that the tangent and then the curve share the same gradient at a certain point. So this shall be equal to 2. And then if I take this 2 to this other side, I'll have it as negative 6 being equal to 0. So x squared minus x minus 6 shall be equal to 0. So now when I solve this quadratically, I can find x as either being equal to 3 or x being equal to negative 2. So when x is 3, I can see that y shall be equal to negative 5 over 2. Then when x is equal to negative 2, y shall be equal to 25 over 3. So therefore the 2 points are 3, negative 5 over 2, and negative 2, 25 over 3. And those are the answers they wanted. Alright, so lastly, I have an exercise for you. These are numbers I encourage you to try out in your free time, and then compare your answers to the answers that you actually see in brown color right here. So these are the answers you're supposed to get when you solve the numbers correctly. So try them out and compare. So I encourage you to pause the video and copy the questions and then try them out. So questions continue. This is question 7, 8, 9, 10. It's 10 part 1, part 2, and then lastly we have number 11. So copy these questions, try them out, and then get better at your knowledge of tangents and normals as an application of differentiation. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If it did, feel free to share the video with all your friends and help as many as you can. And then if you really like the video, feel free to give the video a like or a thumbs up, and then tell me in the comments if the video really helped you, and I'll try to get time and reply to your comments. And then if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Thank you so much for watching, and I'll see you in my next video.